Hey everybody, I wanted to do a quick video for you to do some practice drug math. I've done a few videos, over the last couple of years and one again even a few weeks ago, but it's just such a commonly asked about thing. A lot of people get kind of mentally hung up on the idea of doing drug math and think it's going to be this kind of chaos and lack of a system and everything, but I'll show you the way I do it, and I've found that it works very well. A lot of students, once they get kind of the habit and the practice of doing it, then they're just much more likely to kind of find that routine. And once you get that method down, then you just plug and chug the numbers and you're good to go. So if you see a drug math question like a dopamine infusion or something on your national registry, then you actually get to that question and you feel like it's a confidence boosting question because you know exactly how to do it. So I'm going to do two problems here just to kind of highlight what it can look like and how I do it. And hopefully you find it helpful and you can give me some feedback and let me know what you think. So let's jump right in, all right? So this first question I did is a lidocaine infusion, right? So you're ordered to give lidocaine at 4 milligrams a minute to a patient in ROSC. You have a 500 milliliter pre-mixed bag containing 2 grams of lidocaine. Using microdrip tubing, which is 60 drops per milliliter, how many drops per minute will you administer? And so all the information you need is in the question, right? And it's just a matter of kind of breaking it out and saying, what are those bits of information that we need? So we run with the various components, right? And we have a dose of lidocaine at 4 milligrams a minute. So I like to just list everything out. Our dose is 4 milligrams per minute. We also have a 500 milliliter premixed bag that contains 2 grams of lidocaine. Right, so that's its packaging, we say, or the concentration is another way of saying that, packaging or the concentration. So the concentration of lidocaine that we're carrying is a 500 milliliter bag containing 2 grams, right? And we can really verbalize it either way, right? We can say there's 500 milliliters of fluid contains 2 grams of lidocaine, or we can say 2 grams of lidocaine is contained within that 500 milliliters of normal saline, right? So we can really talk about it either way. And so we have this 500 milliliters and 2 grams. Now, another component that we have is our microdrip tubing. And so the tubing that we have is 60 GTT per milliliter, right? And that GTT is goutte, I think is how you say it. I believe it's Latin. It means drops, right? So 60 drop tubing. Sometimes you'll hear a lot of people reference it that way. So this 60 drop tubing or this microdrip tubing or the 60 GTT per ml. This means when we're looking at that IV chamber, IV drip chamber, every time we count 60 drops going through there, that means 1 milliliter fluid went into our patient. Right? Count another 60 drops going through the chamber, another milliliter of fluid went in. Right? So then what we have is we can speed up or slow down how quickly those drops are going through. But whether the drops are going really fast or whether the drops are going really slow, it still means once 60 of them go through, 1 milliliter fluid went into that patient. Okay? So those are the kind of the core immediate numbers that we need to pull out for a medication infusion, or these 3 variables, the dose, the concentration, and the tubing. And we're going to lay those out for how we can actually mathematically do it. But what's important to understand is what's our goal, right? And our goal is drops per minute. Right? And drops per minute is going to be the GTT for drops per minute. So the drops will be on top, the minutes will be on bottom. Right? So we're looking at it, we've got a dose of 4 milligrams per minute. Right? I don't have an issue with milligrams. Minutes I need, right? Because I have to get drops per minute. I have a concentration of 50 milliliters, all right? And I have 2 grams, right? So this is going to be one of the issues that we run into is our dose is in milligrams, but our concentration is in grams. Right? Another piece that we have is tubing. Right? We've got GTT per ml. GTT I'm happy about, and ml I'm okay with, because I've got mLs here and I've got mLs, milliliters there. And so overall, my units are pretty good, except for the 4 milligrams per minute and the fact that I have a 2-gram bag of premixed lidocaine, and get a little bit extra space. So another fact that we need, right? If we just made a list of facts, right? The fact that we need to solve this one is understanding that 1 gram is the same as 1,000 milligrams. And 1 gram equals 1,000 milligrams. And that's just a fact. Go talk to anybody. 1 gram equals 1,000 milligrams. We don't need any other facts, though, in this situation. Right? We just have the 1 gram equals 1,000 milligrams, and that's going to solve the issue that we're having with our dose in milligrams, but our concentration in grams. So what I like to do is first make sure our units are all together. So 2 grams, right? If we just kind of took a look at this one, 2 grams, we got to get it to milligrams. And so we could just look at it, and kind of mathematically it's probably going to just make obvious sense to a lot of people. If 1 gram equals 1,000 milligrams, then 2 grams is going to equal 2,000 milligrams. Right? 1 gram equals 1,000, so 2 grams equals 2,000. Right? But if it didn't, and we wanted to convert that grams to milligrams, the way we could set it up would be 2 grams, or make little boxes. And so that's the amount that we're trying to convert, is 2 grams. And so the conversion factor that we have is this 1 gram to 1,000 milligrams. So the conversion factor, right, part of the way this setup has to work is putting the units on top and on bottom of these little boxes that we're going to make. And so we have 2 grams on top, and we have 1 gram on bottom. And so when we have the same units on top as we do on bottom, those are going to go away. All right, so we're going to cancel units top to bottom, and then we're going to multiply across. All right, so 2 times 1,000, right? And we can get our calculator. Again, just if there was ever a doubt about doing the math or you weren't that comfortable with it, it's not a problem at all. Nice part is National Registry allows you to pull up the little calculator widget on the test, the computer inside that testing center, so you don't have to figure out any of that math. All right, so we're going to do 2 times 1,000, right? And that's going to give us 2,000. So multiplying across the top, 2 grams times 1,000, we just figured out was 2,000. And on the bottom, the only thing that we have is this 1 left over. So we could just put that 2,000 over 1. If you go back to some probably older math, and just remember that any number, if you put it over 1, is that same number, that top number stays the same. So 2,000 over 1 is still the same as 2,000. And the only units that we have left is milligrams. Okay. So again, a lot of you probably saw if 1 gram equals 1,000 milligrams, then 2 grams equals 2,000 milligrams, and you're good to go. But again, that's the way to set it up if you were ever a little bit unsure about how to actually make that conversion. So now we have our dose and we have our concentration, which we can now write as 500 milliliters and 2,000 milligrams. Okay. And we have our 60 drop tubing. So for medication infusions, the way I do it, and I'm going to again, just get us a little bit more space. We're going to do dose times concentration times tubing, okay, equals our drops per minute. And that's what we're going to do. Right, so I like to set it up kind of with the same boxes as I did for converting the 2 grams to 2,000 milligrams. For dose, we said it's 4 milligrams per minute. Now, a lot of people like to have the visual of a number, right? So if we're saying it's 4 milligrams per minute, right? 4 milligrams per 1 minute. Right? So that's our dose. And concentration is our next piece that we're going to do. Right? So our concentration, we said we've got 500 milliliter bag and we have 2,000 milligrams. So remembering what we said about these units on top and on bottom have to cancel out. Right, so I've got 500 milliliters and I've got 2,000 milligrams. So I have milligrams on top here. So I'm going to need to put milligrams on bottom here so that those units cancel out. Because at the end of it, the only things I need left over are drops per minute. All right, so 4 milligrams are on top for that one, and I'm going to put milligrams on bottom for my concentration. That was 2,000 milligrams. And the other part of my concentration was 500 milliliters. All right, so that's my concentration part. All right, we're just laying everything out right now. We haven't done any math yet, really. Now we're just laying it out. And then our tubing, we have 60 drops per milliliter. Okay? And we have milliliter on top. And so let's make sure that that milliliter goes on bottom to cancel it out. And we have our 60 drops per milliliter, or per 1 milliliter. And so now taking a look at it, we have milligrams on top and milligrams on bottom. Those go away. We have milliliters on top and milliliters on bottom. So those go away. And all we're left with are drops on top and minutes on bottom, which is exactly what I was trying to get. Okay. So I have all these boxes laid out. And what we do is we cancel those units top to bottom, but then we're just going to multiply across. Okay. So we're going to do 4 milligrams times 500 times 60. Okay. So let's get my calculator back out. Okay. We have 4 times 500 times 60 equals 120,000, if I saw that right. 120,000. Cool, so that's just the top, right? 4 times 500 times 60 on the calculator gave us 120,000. 1 times 2,000 times 1 is the other piece of it. And again, we can pull our calculator if you're ever not comfortable with the math. 1 times 2,000 times 1. All right, remember, anytime you multiply something by 1, it is the same. Right? So 1 times 2,000 times 1 equals 2,000 on bottom. Okay. So I've got 120,000 on top, and I've got 200,000 on bottom. So mathematically, that's 120,000 divided by 2,000. Okay. So go back to our calculator. 120,000 divided by 2,000 equals 60. Okay. Equals 60. 60 what? 60 drops per minute. Okay. 60 drops per minute. Okay. And so going back to our question, right, where it says we're going to give our patient 4 milligrams a minute. Here's how much medication we have. We have 2 grams and we have 500 milliliters of fluid and we have micro drip tubing. Okay. So counting 60 drops going through that drip chamber over the course of the minute, based off of how much medication is contained and how much fluid we have, is us giving our patient 4 milligrams per minute of that medication. Now remember, milligrams is kind of a weight, right? So if we had powdered lidocaine and we could put it on a scale and weigh it out, right, we would give 4 milligrams of that medication every minute. But we have to put it into a fluid so that we can administer it IV. And so that's why that concentration comes into play, right? And then it's just multiplying across the top and across the bottom. So hopefully that was helpful, right? Was that lidocaine infusion. And kind of the most complex that you're likely going to see is something similar to a dopamine infusion, which is the next problem. All right, so in our dopamine infusion, it says you are ordered to give dopamine at 6 micrograms per kilogram per minute to a patient in septic shock. Your patient weighs 180 pounds. You have a vial containing 400 milligrams of dopamine and a 250 milliliter bag of normal saline. Using micro drip tubing, which is that same 60 drops per milliliter tubing. How many drops per minute will you administer? So let's just pull out the information that we have. We have a dose, which is 6 micrograms of dopamine per kilogram the patient weighs per minute. Okay? So we're going to give 6 micrograms of dopamine for each kilogram, every 1 kilogram the patient weighs, every minute. And so slightly more complex than our lidocaine infusion, because now we actually have to factor in a weight for this patient. It's a weight-based medication. All right, so we've got our dose. We've got our patient weight, which is 180 pounds. We have a vial containing 400 milligrams of dopamine and a 250 milliliter bag of normal saline. All right, so that's our concentration again, or the packaging. So our concentration, we have 400 milligrams in a 250 milliliter bag of normal saline. Or again, we can verbalize it the other way around and say we have a 250 milliliter bag of normal saline that contains 400 milligrams of dopamine. Verbalize either way. And we've got our micro drip tubing. Micro drip tubing, which is our 60 drops per milliliter. So we need to talk about facts, right? What facts do we have? We have a dose that is based off of a patient's weight in kilograms, but we have a patient weight given to us in pounds. And so one of the facts that we're going to need is how to convert pounds to kilograms. So the fact for us that we can do is 1 kilogram equals 2.2 pounds. That's the conversion there. 1 kilogram equals 2.2 pounds. Okay, we also have another issue, which is a dose in micrograms, but a concentration in milligrams. All right, so we also are going to need to factor in that conversion. So that one is another one that's a unit of 1,000, right? It's a move of 1,000. So 1 milligram equals 1,000 micrograms. Right? It's the same amount. 1,000 micrograms is 1 milligram. Right? It's kind of like 3 feet is the same as 1 yard. Right? We can say 3 feet. We can say 1 yard. It's the same distance. Right? We can say 1 milligram, or we can say 1,000 micrograms. It's the same amount. So just like we had 1 gram is 1,000 milligrams, we have 1 milligram is 1,000 micrograms. Okay? So with all this information, we're going to be in a good spot. So I always start with the patient's weight, right, when they give it to me in pounds. And so I have a 180 pound patient. That makes my little boxes. Okay? And convert that, I've got kilograms. 1 kilogram equals 2.2 pounds. So if I was going to set this up, I need pounds on bottom, so that I can cancel out my pounds on top. So I've got 2.2 pounds, and I've got 1 kilogram. So multiplying across the top, 180 times 1 is 180. And again, we can put a placeholder 1 there if you need it. And 1 times 2.2 is 2.2. And so I've got 180 divided by 2.2. So 180 divided by 2.2 gives us 81.818181818181. So I usually leave one extra decimal for now, right? I encourage you not to round too early in this. So we have this 81.81818181, right? So I like to just pick that first decimal and just cut it off there. 81.8 is my number. So 81.8 kilograms, because I had pounds on top and pounds on bottom went away. So the only thing I'm left with is kilograms. Another way you can remember that is by just saying kilograms equals pounds the patient weighs divided by 2.2. Right, that's just kind of relaying out what we just did. And so we've got a patient weight in kilograms now, which solves that issue for us, which is the fact that the dose is based off of that weight in kilograms. We're going to give 6 micrograms of the medication for each kilogram they weigh. So they weigh 81.8 kilograms. We're going to give 6 micrograms for each of those 81.8 kilograms that we have. Okay. So that was step number 1, was let's deal with that patient weight. Step number 2, I like to make sure that I get my other units addressed. And so I have my 400 milligrams of medication as my concentration, but I have that micrograms for my dose. So I need to convert that 400 milligrams to micrograms. So 400 milligrams. I'll make my little boxes. And I have my conversion here of this 1 milligram equals 1,000 micrograms. So again, it might be one that if you may just look at it and say, okay, if 1 milligram equals 1,000 micrograms, then 400 milligrams must equal 400,000 micrograms. Right? You'd be right if you looked at it that way. But let's go ahead and just lay it out. I've got milligrams on top, so I got to put milligrams on bottom. And so that's 1 milligram on bottom is the same as 1,000 micrograms. Okay. Again, a visual placeholder if you need to, put a 1 in there. So 400 times 1,000, we're just going to multiply across the top. 400 times 1,000 is 400,000. 400,000. And we've got a 1 times a 1 is 1. And again, any number over 1 is just that number. So we have 400,000 micrograms as that part of the concentration. The 250 milliliters we can leave because we have that amount in milliliters and we have 60 drop per milliliter tubing. So those units are all equal. And so now we're ready to actually lay it out. Right? And we're going to do that same dose times concentration times tubing. Okay. Dose times concentration times tubing, and that will equal our drops per minute. Okay, so let's start with that dose. We have 6 micrograms per kilogram per minute. 6 micrograms per kilogram per minute. So 6 micrograms per kilogram per minute. The first thing we need to do is multiply by that patient's weight, 81.8 kilos. 81.8 kilos. And the reason why we have to do that is because we're giving 6 micrograms for every 1 kilogram. So we're going to need 6 micrograms, 6 micrograms, 6 micrograms, 6 micrograms, all the way up to 81.8 kilograms. Okay. So we do that by multiplying it. So that also will remove our kilograms once we're done with it. So we have 6 micrograms times 81.8 kilograms is 490.8. 490.8 micrograms per minute. And now we just addressed and eliminated one variable, right? One of the kilograms went away. And so our dose is 490.8 micrograms. per minute. Our concentration set as 400,000 micrograms and 250 milliliters. So I've got micrograms on top, so I'm going to have micrograms on bottom, so those go away. 400,000 micrograms and 250 milliliters was the other piece of that concentration. 250 milliliters and 400,000. And then we have our 60 drops per milliliter. I've got milliliters on top, so I'm going to need milliliters on bottom. So I have 60 drop per milliliter tubing. So remember, we're going to cancel units top to bottom. So I've got micrograms on top, micrograms on bottom, those go away. Milliliters on top, milliliters on bottom, those go away. All I'm left with is drops on top and minutes on bottom, which is my drops per minute, which is the goal that I'm shooting for. So this one, again, we're going to multiply across 490.8 times 250 times 60. I got 490.8 times 250 times 60. Very large number. Right, so that number was 7 million. I didn't catch it. 362,000. 362,000. So 7,362,000 on top. And I've got 1 times 400,000 times 1. Again, if you need it, 1 times 400,000. Always be careful when you're using the big numbers and you got a lot of zeros. Slow down, make sure that you get them all in there so you don't make a mistake. So 1 times 400,000 times 1 is still our 400,000. Right. And now I've got 7,362,000 over 400,000, or another way of saying that is 7,362,000 divided by 400,000. That gives me 18.405. 18.405 drops per minute is what that is. But this is the time that you do your rounding, right? Because we get it all the way down to this, which is saying how many drops through that little drip chamber of our IV tubing, how many drops are we actually counting? And so 18.405 drops per minute. I don't know about you, but I can't count 0.405, less than a half of a drop moving through there in a minute. Right? All we can do is there was a whole drop or there wasn't a drop. Right? So we have to round this off to just a whole number. And so what we do, if it's 0.4 and lower, we'll round down. Okay? If it was 0.5 or higher, we would round up to the next whole number. So 18.405, we're going to round that down to just 18 drops per minute. Again, just a side note, if it was 18.7 drops per minute, and it's 0.5 or higher, we'd round it up. So we would say 19 drops a minute. Right? But in this case, it was 18.4, so we rounded down to 18 drops per minute. So I hope this was helpful. Like I said, I know a lot of people struggle with drug math, and it's really just struggling with a system. Right? So once you can identify your pieces, and if you have a method for setting it up, then you're going to be good to go. Right? So this is how I do it. I know there's some shortcut methods that are out there. This one's pretty fast once you actually get it, and the fact that you can use a calculator. You can fly through these problems really, really quickly once you just build up that comfortability with them. And math is very much practice. And the more you can do practice problems, the better you'll get at them and you'll be in a great place. So it's not a matter generally of just doing 1 or 2 problems and then you got it nailed down. Right? It might take a good long while of some practice to really be comfortable with the setup and the ability to kind of work through how to do it. So this video, you can at least go back and watch, as many times as you want to really kind of slow down and follow each of the steps. And then what I would encourage you to do is, go to these types of problems that I laid out up here and just start changing the numbers up. right? And just kind of make up your own problems and say, okay, I'm ordered to give dopamine at 20 micrograms per kilogram per minute. My patient weighs 75 pounds, and I've got 800 milligrams of dopamine, and I have a 250 milliliter bag, and I'm using macro drip 10 drop tubing, right? Just change up those variables and practice just being able to set it up and to work through it properly that way. But I hope it was helpful. Let me know if you have any questions, and maybe I'll get some more practice problems out there for you. But I think this will be a good resource for a lot of people to be able to go back and reference. So again, thank you, and I hope you enjoy it.